Hello viewers, welcome back to BakoMaths. And today's video we'll continue our lessons on ordinary differential equations, specifically linear differential equations. And if you have not subscribed to this channel, consider subscribing so that when a new video is being uploaded, you'll be the very first person to be notified. Here there are two examples, and we start with example 1. It says that find the differential equation y prime is equal to f of y satisfied by y of t is equal to 4e2t plus 3. So what this simply means is that there is a differential equation that gives us this solution, or there is a differential equation that has a solution as 4e exponential 2t plus 3, and therefore we must find that differential equation. So since the only thing we have here is the solution to the differential equation, we use that to solve. So y of t, of which you can write the same thing as y, knowing well that this y is a function of t. So y is equal to 4e exponential 2t plus 3. So to get that particular differential equation that gave us the solution, we first have to consider differentiating the solution. So when we differentiate this, we now have y prime is equal to, so here 4e exponential 2t, we can apply the product rule in differentiating, which means we first maintain 4 and then we differentiate e exponential 2t. So in differentiating e exponential 2t, we have to know that it's an exponential function. So in differentiating exponential function, we first have to differentiate the exponent. So in differentiate the exponent with respect to t, we now have 2, which multiplies everything as e exponential 2t. Now remember, first we maintain 4, so the next thing is to differentiate 4. 4 is a constant. When we differentiate, we have 0. Now you multiply by e exponential 2t maintained, so that is e exponential 2t, and then we also have to know that there is 3 here and the differential of a constant 3 is 0, so which means that our y prime is equal to 4 multiplied by 2e exponential 2t, and the rest gives us 0. Now we continue and we can see that since multiplication is commutative, we can rewrite this as 2 multiplied by 4e exponential 2t, and we call this as equation 1. We just interchange the position of 2 and 4, so we call this as equation 1. Good. So from the same solution again, so again from the same solution of what we have, that is y is equal to 4e exponential 2t plus 3. We consider making 4e exponential 2t plus 4e exponential 2t the subject, so that we can easily substitute in equation 1, and with that we get the differential equation we are looking for. So our solution continues to make 4e exponential 2t the subject. We can now write it as y minus 3 is equal to 4e exponential 2t, of which we can also write it as 4e exponential 2t is equal to y minus 3. Now we can call this as equation 2. So the next idea is to substitute equation 2 in 1, and with that we get our differential equation easy. So by substituting, let me write here, by substituting 2, that is equation 2, into 1, then what do I have? I have y prime to be equal to 2. So 2 multiplies 4e exponential 2, so we have 4e exponential 2 in equation 2 as y minus 3. So our solution continues, and here we now have y prime to be equal to, so 2 multiplies y, we have 2y, and 2 multiplies 3, that gives us minus 6, and hence this becomes the differential equation you are looking for. So it means that this differential equation give us the solution of y of t is equal to 4e exponential 2t plus 3, and we've been able to prove that nicely. So that is that. Now we continue with example 2, and in example 2 it says find the differential equation of the form y prime is equal to f of y satisfied by the function y of t is equal to 8e exponential 5t minus 2 on 5. So it's basically the same idea as we did in example 1. So you want to find that particular differential equation that gave us the solution. So if that's the case, then we consider the solution of the differential equation as given in the question. So that is y is equal to 8e as power 5t minus 2 on 5. So we don't bring the t here because the same thing, we can choose to bring it or we can choose not to bring it. At the end, we have to bear in mind that the y here is a function of t. So now what do? We continue by differentiating what we have here. So we differentiate this with respect to t, then we have y of t is equal to, that is y prime is equal to, so 8 and e as per 5t are multiplying, and we can apply the product rule, which says first maintain 8 and then differentiate e as per 5t. So when I differentiate that, because e is an exponential function, I first differentiate the exponent with respect to t. So when I differentiate the exponent with respect to t, I have 5. So this 5 now multiplies everything as e as per 5t. Now you can remember that initially I maintained 8 and I differentiate this. So the next thing is to what? Is to maintain e as per 5t and then differentiate 8. So if I differentiate 8 is a constant. So when I differentiate it gives me 0, and then I now maintain e as per 5t, and then we can also see that minus 2 on 5 is a constant. So differential of a constant is 0. So when we continue with our solution, simply means that y prime is equal to 8 multiplied by 5 e as per 5t, and then the rest gives us 0. And we know that multiplication is commutative. So if that's the case, then we can interchange the position of 8 and 5, and that gives us 5 multiplied by 8e as per 5t, and therefore you can call this as equation 1. So we continue our solution by making reference to the same thing, like by making reference to the same solution as given the question. So from the solution, that is the solution of that particular differential equation, that is y is equal to 8e as per 5t minus 2 on 5. We intend to make 8e as per 5t the subject so that we can substitute into equation 1, and with that we can get our differential equation. So by making the subject, then we have y plus 2 on 5 is equal to 8e as per 5t, and here we can see that it's the same thing as 8 e as per 5t, which is y plus 2 on 5. So you can call this as equation 2. So the whole idea is to substitute equation 2 into equation 1. And if that happens, then it means that our y prime, now is equal to, so if I send this up a bit, then I'm going to have, so let's scroll up a bit so that yes, you can write there. So it means our y prime now is equal to, so it says 5 from equation 1, so 5 multiplied by 8e as per 5t, but we know that from equation 2 as y plus 2 on 5. So here we continue and we have our y prime to be equal to, so 5 multiplies y gives us 5y, and then 5 multiplies 2 on 5 gives us 2, because the 5 will consider 5, and this becomes the differential equation we are looking for. So just like we said, this differential equation amounted for the solution y of t is equal to 8e as per 5t, and that is it. So this ends today's video here, and you can check out the next video or the next lessons under ordinary differential equations. Do not forget to subscribe to BakoMaths. Thank you. So thanks for watching. Kindly like, comment, subscribe, and share. This is BakoMaths, thinking beyond infinity. See you in our next video. Bye bye for now.